Hello everyone. Today we are going to discuss the fifth problem of AtCoder beginner contest 321, which is complete binary tree. The problem statements of this round are, I think, straightforward, not that much of story. So that's why I enjoyed solving these problems. So what is the problem? We are given a tree, complete binary tree with n vertices from 1 to n. And what is a complete binary tree? Let me explain you. The complete binary tree is nothing but where the left child will be, let's say the parent is I, then the left child will be 2 into I, and the right child will be 2 into I plus 1. Okay, that is a complete binary tree. So it will be 2, the left child of 1 is 2, 2 into 1, and right child will be 2 into 1 plus 1, which is 3. Similarly, it will be 4 and 5 and 6 and 7, like that. Okay. Now, and another one important thing to observe here is that any level rather than the last level will be full. Okay, that is another property of complete binary tree. Let's say we have let's say we add another node, let's say 8 here. So you can see at the last level, the fourth level is incomplete, but every other level is complete. So that's why we call it complete binary tree. Okay, and this property will help us solving the problem. Okay, so let's jump into the problem statement again. So find the number of vertices whose distance from vertex x is k. So we are given t test cases, and in each test case we will have n, which is the number of nodes, x the given node, and k is the distance. So let's say here we are given, let's say from node 2, what are the nodes, what are the count of the nodes which is at distance 2. Okay, so there is only one node at distance 2, which is 3, because let's say this is one edge and this is one edge, so distance is 2. So from 2, let's say our node is 2 and distance is 1, then uh, sorry, distance is 2, then our count of nodes, count is 1. Okay, now we are only checking for node 2. So node 2, distance 1, what are the nodes which is at distance 1 from 2? It will be 4, 5 and 1, so answer will be 3. Okay, similarly, what are the nodes at distance 3? They are 6 and 7. So for from node 2 with distance 3 will be 2. So you can see this example, the first examples, we have 10 nodes, and our x node is same 2, and we have to find the number of nodes with distance 0. The number of nodes from 2 with distance 0 is only 2, so the answer is 1. So you can go through this example. I'm not going to explain each and every example. So let's jump into our solution approach. Okay, so before jumping to the solution, let us check what is the constants and what could be the possible time complexity. So here t is 10 to the power 5 and n is 10 to the power 18. Okay, so you can see that we can't do order of n. So order of n could not be a factor of the solution. So something into order of n will also not work. So you can think of order of log n. Log n is around 60. Okay, so the time complexity will be t into order of log n, or I have solved using t into order of log n square, log squared n, you can say. So this would also suffice. So I think there could be some better approaches with order of log n, but my approach is quite simple, I think. So what I have done, solution approach, let's say we have this tree only 1 2 3 4 5 6 7, 1 2 3 4 5 6 and 7. So what I have done is that let's say I am at node 2. What I will find, I will try to find all the nodes which are at distance k in each subtree. Okay, so we will find all the nodes which are at distance k in each subtree. Then we will jump out of this tree to the parent. Okay, then we will try to find all the nodes which are at distance k minus 1 in its right subtree. Okay, in its right subtree with k minus 1, or you can alternatively say we'll try to find all the nodes at distance k minus 2 in the right subtree of 1. Okay, that's what I have done. So I think going into the code will be better, you will understand it better. So this is the recursion part when we are going to the parent node. We can do it in a for loop by decrementing the value of node by dividing it by 2, going to the parent. So what I have done is that our left node, what are the parameters of rake? First, the parameters of rake are nothing but the current node, the previous node, and k. Okay, so why I am taking the previous node? So let me tell you that. So let's say our current node is let's say this example 1 2 4 5 and 3 6 7. Okay, so let's say we jump from 2 to 1. Now we don't want to check this subtree. Okay, so our previous node will be 2 and our current node will be 1. So we will not check the subtree of previous. Okay, that's what I have done here. So left equals to node into 2, I have already told you, and right equals to node into 2 plus 1. So if uh, let's ignore this one first. So if left equals to prev, that means that we have already checked the left subtree, so we'll check the right subtree with k minus 1. Okay, and otherwise we will check the left subtree. I hope you got it. If previous node is left one, then we will go for the right subtree, and if previous node is right one, we will go for the left subtree. I hope you got it. Now what is this thing? This thing is nothing but the recursion. We are going above. So let's say we are at node 2, we will go above. So our parent will be nothing but, if we are at index 2i or 2i plus 1, our parent node will be, let's say our node is node, so our parent node will be n by 2. Okay, I hope you got it. That's what I have done here. Node by 2 is nothing but parent. Parent is our current node, and our previous node will be the current node, and k will be decremented by 1. Okay, now what is check? This check function is quite interesting. Check function does what? Okay, so check function does the same thing I am saying here. Let's say 4 5 3 6 and 7, let's say 8 here. Okay, so we will try to find the number of nodes in the subtree of 2 at distance 2. Okay, so we'll try to go to the leftmost of the two subtree. So let's say we are at index at node 2. We'll try to find the kth level. Okay, so from 2 to the first level will be 4, and left child of the fourth in the next level, second level, will be 8. Similarly, we'll try to find the rightmost node in the kth level, so it will be 5 and 10. Okay, I hope you got it. We'll try to find the leftmost node in the kth level and the rightmost node in the kth level, so 8 and 10. But you can see that our number of nodes is 8, so we have to take minimum of 10 comma 8 here. So that's what I have done here. I am going to the leftmost node here at kth level. If left is greater than n, let's say we are going at the third level, but there are no nodes in the third level, so we'll just return. uh, and similarly we go to the rightmost level, and we'll taking minimum of right comma in minus minimum of left comma in. This is not needed, you can directly do left, because if left greater than n, we are already returning 0. So instead of this, you can write left plus 1. Okay, I hope you got it. What is the initial call? The initial call will be, we are going to the parent of x. We are going to the parent of x to check this. So our node will be x by 2, and our previous node will be x, and our distance will be k minus 1. Similarly, we are checking in the subtree of x, will be checking the subtree of 2. Okay, I hope you got it. If you have any doubt in any part of the video, there are two functions I have already explained. The first function to find do the recursion or going to the parent, and the second function is actually calculate the number of nodes in the subtree at distance k. So this function is the most important one. This is exactly not needed, you can do in iteration also. Some iterative approach will also work. If you have any doubt in any part of the video, you can rewatch that part, or you can write in the comment section. I will try to reply each and every comment. I will also give the link of the code in the description box, you can go through that. If you find this video helpful, please like the video and subscribe to my channel. Thank you.